hi, hello, and other such phrases. I'm the Defective Brain, and I'm here to give you an in-depth look at some of the latest microbiology publications. The link to the original paper is in the description. Feel free to read along at home. If you're more interested in the subject, then feel free to join in the discussion with the Microbiology Twitter Journal Club this Tuesday at 8 PM BST. Anyway, let's get into the paper. Cell division isn't one of the most sexist of topics out there, but by God, this paper, published in PLOS ONE, does its very best to tart the subject up. FtsZ, placement in nucleoid-free bacteria, is chock full of shiny pictures of glowy bacteria. But we can't let the sheer prettiness of this paper sway us. Let us cast a critical eye and examine the evidence presented before us. When a cell grows big enough to split into two, it pinches in the middle. This initial pinching is caused by FtsZ, a protein that forms a chain around the middle of the bacterium, which then shrinks, pinching it off. But before it even gets to this point, the cell needs to make sure that the Fits forms this chain in the right place. This is where the MIN system comes in. This is a series of proteins which stop Fits forming in random points along the cell. The MIN team members are MIN-D, MIN-C, and MIN-E. MIN-D binds to the membrane around the cell poles, and when a group of them get together at the pole, it binds MIN-C. And MIN-C is important because MIN-C stops Fits in its tracks. Then there's a final member of this group, MIN-E, which forms a chain that chucks MIN-D out of the membrane, causing it to break away from MIN-C. A ring of MIN-E's goes up and down the cells, breaking off these interactions as they form. The middle of the cell is generally swept clean of MIN-C, allowing space for the Fits to form chains. But the cell also needs to watch out for its DNA. If it pinches off at the wrong time, the bacteria's chromosome could get ripped in half. A protein called Slim-A guards the chromosome until it's safely out of the way of the Fits. But that leaves us with a conundrum. We know both of these systems act on Fits, and we really want to know about what the MIN proteins are doing. But there's this whole other system confounding our experiments. So what do? It's simple. We kill the chromosome. UV light in high enough intensity can annihilate DNA by introducing breaks in the strand. The longer the strand of DNA, the more vulnerable it is to being destroyed by UV radiation.